Yeah, can I start from the first topic?
Yeah.
Yeah, okay. Now I'm sharing the screen. Are you visible to see this?
Yeah.
Okay. I'm attending on the phone because I have a little bit problem on system.
No problem.
Yeah, okay. Yeah. Now coming to the variables. Okay, I'll start. Okay. Variables are the data that will keep on changing. Um, variables means it is a variable name that we declare a particular name to a C program. Sorry, the code. So it is always keep changing because we will change the name for each code. So that's why it will keep on changing. So how we declare the variables are, first it will be a data type, and next we will give you a variable name. Data type means it is int, character, float, like that. And now variable name will be a, b, or a, it will be an integer also. We can declare as an integer also. So here are the examples of declaring the variable and definition of a variable and uses of the variable. Now coming to the variable rules, it should not be a reserved word like a int, float, or etc. It must be start with a letter, like abcd or an integer, or it will be start with an underscore. So there is no other special characters like a module, a percentage, like that. So here variable names are really case sensitive because caps a and small a are really very different. It will take a different it will take as a different variable like a caps a or a small a. So now coming to the data types. Data types are the data are defined as a data storage, and data types are four types. One is the basic data types and user defined and derived data type, and void data type also will become in a basic data type also. So now in coming to the basic data types, there are int, character, float, and double. So these are the storage values and the range between the basic data types. So you can see this. I want to explain these also, or are you okay for that?
Yeah, yeah, sure.
So first coming to the integer storage size is a 2 bytes, and character size will be a 1 bit, and the range between in the right column section. So now coming to the user defined data type, there are e-number, structure, union. So coming to the e-number means enumeration. Enumeration data type is consists as a named integer constants. So it will start with a 0 by default. By default only it will start with a 0, and the value will be incremented by 1 by 1. And next, the e-number syntax is e-number identifier, and we will give you optional that's our wish, and enumerator list. So now coming to the structure. See, structure is a collection of different data types. Okay, wait.
Wait a second. Structure is mine, I think so.
Okay, sorry.
Yeah.
Yeah.
I have a small doubt in enumeration.
Yeah.
Like, you have any examples for enumeration?
Enumeration. I don't take an example, but wait 1 minute.
Okay.
Um, the list will be okay. E-number identifier means we can take as identifier like any type of identifiers. So I can tell the enumerator list. We can take it in the braces. Sorry, what's this? Okay, we can take the braces list is like integers. Yeah, I
Okay.
mentioned here in the first topic, named integer constants as a list like that. We can take it like there is no particular example. Uh, okay, later I will tell it.
Okay.
Yeah. Mm, coming to the union, it is like a structure. Whose first you want to explain the structure, then union will be understood. Well, I
I
will
think
tell
you
about the
check it.
derived data types, and the last I will tell about union data type.
Okay.
Okay. See, yeah, it was first showing that C union is also like a structure. So, well, first we understand the structure, then it will be easy to understand union. So, for I will tell you later about union. First, I'm next I'm telling about derived data type. So, coming to the derived data type, there is
Priyanka,
the
wait a second.
pointer array
Ma'am, Priyanka, wait a
that
second. I think pointers is Sandeep's topic and array is my topic.
No, she can just brief it out because it's part of the derived data types. Maybe she can brief it out. Won't be fair, right?
Okay. Because we won't be having anything to tell after that.
No, we'll be putting up the examples and all that.
Okay, cool.
okay, then I'll tell about a void data type.
You can tell about derived data type. It's okay.
Yeah, okay. So coming to the void data type, void is means it is a empty data type. This can be used in a functions and a pointers also. So uh, there is a okay. Please be sorry. Void data type information. We can show a example in a call by value and a call by reference. The void data type means if you give a void int and in a bracket there is a statement, the void will be taken as a null value. That means empty value. It will take it. It will does not fill it with a garbage value or anything else. It will. It is an empty. Okay, we can't declare anything in that. If you declare a void main, it was just okay. It was not considering the main. That's about it. And next is okay. My topics are over 1 2. No.
Okay. Mhm.
Yeah,
Yeah.
yeah. You can start
Sandeep,
yours.
should I continue?
Yeah, yeah, yeah. We'll go in the same sequence.
Okay. Priyanka, you
Okay.
can unshare your screen.
Yeah. Yeah. Okay.
Okay. I'm sharing my screen here.
Okay.
You guys are able to see my screen?
Yeah.
Okay, cool.
Yeah.
So my topics here are reading input output. Sorry, reading input and writing output and arrays are my topic. So I have PowerPoint presentation for that. Just a second. Okay. So the first one is reading input. In C is a structural programming language where it uses functions for reading or writing the data. So here for reading the data, we make use of scanf function. It is called a scan function. So here we have few attributes here to be filled inside the function. That is, if it is a integer, it is called with percentage %d. If it is a character, it is called with percentage %c. If it is a string, it is called with percentage %s. And if it's a floating point, it's called percentage F, and if the decimal point is called percentage, I think double. Yeah. So these are the following what do you call it, specifiers, which are used inside the scan function. And here we have, if you want to store something else, if you want to store a data inside a variable, the variable should be declared in advance. After declaring a variable, you have to specify in which variable you want to particularly store the data in. So if you see the example over here, int I, there you're declaring the int, you're declaring the I as a variable. You're just declaring it, you're not assigning anything. And then in scanf, that is a function which you're using for reading the variables. In scanf, we know we're going to read the data which is integer. So we use percentage %d, and then uh, we put the dollar sign, sorry, and sign, and we mentioned as I. That means that whenever you scan data, the data should be read and stored inside this particular variable I. So this is how we're going to read the data in C program. And for printing the data or displaying the data, even for printing and displaying the data, we use a function called as printf. Here printf, the difference between printf and scanf is that we don't, the basic difference is we don't scan, we print it, we display it. But here also we have to specify from which variable are you printing the value, or and what type of value is it. So for printing a value or for printing a data, the data should be stored in advance. So if you see the example over here, int a equals to 90, which is a defined variable is assigned with 90 as a value. And in printf, in function, we specify which type of which type of data we are printing. That is integer. So we mentioned that percentage %d, and then we are extracting the data from the variable a, which is 90, and it will get printed. So this is how you print or display a data in C program. And coming to arrays, array is basically a storage element which stores data which are having a same what do you call that, data types. So all the data contains the same data type. If you want to store integers, or if you want to store numbers or set of numbers in an array, the array should be defined or declared with an integer array. Or if you want to store a sequence or set of strings, set of names, where name is a string. So even the array defines the example, it is int a 50. That means that we are storing integers inside the array with the name. The array came with the name of a, and the capacity of the array is mentioned inside the square bracket. If there is nothing mentioned inside the square bracket, the capacity, it doesn't mean the capacity is infinite, but then how much ever you can store, you can store. And the very important thing for in coming to array is that whenever you're printing it, we should remember that the sequence is starting from the index number 0. Anyway, the array starts with 0 and ends with a garbage value. So if you want to predefine something, it'll be over here. I'll show you the example, compiler example, how it works. So this is the array. Let me comment this out. we have written an array, which is a data type of int, and then we mentioned the name of the array, which is a, and the capacity of the array, which is 5. And then we give a set as 1, 2, 3, 4, 5 are the elements of the array. And if you have to print the array, print the elements of the array, you should be using a for loop so that it will iterate through the array, across the array, and print all the values which are inside the array, which are the elements. So I initialized a variable I assigned with 0, and I told that it should go until 5, the index number is 5, and then increment the I, so that will print an integer. That's why I mentioned percentage %d, so it's where it will print integer, and the elements of I it's mentioned over here. If I run this, I should supposedly get the output. Yeah. So if you run this, I get the output over here: 1, 2, 3, 4, 5. We are getting whatever elements are there present inside the array. That'll get printed over here because of the for loop. Without an iteration, you can't print an array. You can only print a single element from an array without the for loop. So that is for the arrays. Let me come here. So I've completed my 2 topics of now for now. Writing and reading, and arrays I've completed. So next is Sandeep's.
Okay.
I'm unsharing it.
Yes, screen. Yeah. That is slide, but this is sliding, right? I hope that. Yeah. So guys, is the screen visible?
Yeah, it's visible.
Okay. Yes. Starting with the control statements. Okay. So control is basically like it's basically depending on its condition. If this condition is true, then a particular set of statements is executed. If false, this particular set of statements are executed. Okay. Starting with the control statements, we have 2 main parts. One is called branching statements. The other one is looping statements. Okay. Starting with the branching, so we have got 4 here with us. So in the branching, we have if, else if ladder, switch statements, and conditional operator. Okay. Coming with the first one, switch if syntax. Sorry. So if this is the syntax, I'm just telling out the syntax. Basically, what if does is it first checks for a particular condition. Let's say here. Yeah. So yeah, this is the syntax. Okay. I hope you can see this. So in
Yes,
the
yes.
condition, we're going to pass this condition. The condition will return either true or false. If the condition is true, only then this expression is executed. Expression or expressions, multiple expressions or single expression will be executed. If this condition is false, then this particular expression will not be executed. Okay, this is if syntax. Yeah. Next is else if. So here what happens is first we are passing a condition. So let's say any condition. I'll just show you with the demonstration now. So if first we'll check for the condition. If the condition is true, then this part of the expressions is being executed. If this condition is false, then this part of the expressions is being executed. So this is a basic if else. Okay. So moving to the next. Yeah, so this is fine. Fine. Coming to switch statement. So here what happens is, let's take a variable. Say we have got, yeah. Good. So we've got, say something called c is equals to 5. Okay, I'm sorry for this example. So what happens is I'm going to pass the control variable C over here, telling this is C. Okay. So what happens is that's a control variable. C is a control variable. Now these are the cases. So here cases, what we're going to do is we're going to tell whether the output, whether the C is 1 or 2 or 3, 4, 5. These are the control statements. Okay. So we're going to check whether this control variable is equal to this constant. When when this control variable is equal to this constant, this set of statements will be executed.
Wait
Okay.
a second.
Yeah.
So the C equals to 5 will be in the control variable place, right?
Yeah. So what we're going to do is we're going to pass switch of C. Switch inside the parenthesis, we're going to pass the C.
Okay, okay,
And
okay, okay.
these are the cases. What are the possible cases that that particular value can be?
Yes, yes.
Okay. Based on that, these are going to execute. So if
Mm.
the, for example, if C is equals to 1, so let me say that if my C value is 1, that's wrong thing, yeah. So that time what happens? I'm sorry guys, some weird things happening. Okay. Let's say C is equals to 1. So that time this particular statement is being executed. Okay. And then we are giving a break here. Okay. Break is nothing but an, it's called as unconditional statements. So it breaks the entire switch and comes out of the switch. If you're not giving this break statement, then what happens that the next case is going to be in checked. Is It'll again check for the next statement. So in order to reduce the processing time, so we're going to give this break. It comes out of the switch. Else is going to check for this variable, every other case is going to check. Now coming to the default here, is mine clear or you have any still more doubts? I'll be demonstrating the same
No,
in
no, clear.
coding also.
It's clear.
Last is the default. Let's say that I've given here option 1, 2, 3, 4, and 5, right? Let's say my variable I pass is 10. So neither of the cases is satisfying. So that time it comes to the default. Yeah, default, when no any cases, the entire cases, it's nothing is matching, then it comes to default. In the default, what are statements have been mentioned here, those statements will be executed. This is a switch syntax. Okay. So switch syntax can also be executed such a way like a continuous if-else ladder. We can also do the same switch operation using a continuous if-else ladder also. I'll show you with a small demo. Next is, let me clear these. Yeah. Yes. Last is a conditional operator syntax. This is also known as ternary operator. So this what happens is first, this is a syntax here. So you can see the syntax here. And do not mind, this arrow is just to indicate this text. I hope it's clear. Here I've given the example. So here first we'll give a condition and we're going to pass it with a question mark. And if this condition is true, then this particular first line is going to be executed. If this condition is false, then the second line will be executed. Okay, I've just mentioned a example here also. Let's say this. Let's say that we have a flag variable and we are passing a condition here. Okay. Let's say 5 is less than 0. Is it true or false?
It is false.
Yeah. So it is false. So that time what happens? Only when this particular condition is true, the flag will be initialized with the value 1. If this condition is false, the flag will be initialized with 0. Okay. So here, let's say that flag output is 0. Okay. Next line, if you say that flag is equals to 5 is greater than 0, 0. Over here, so what would be the output this time? What will be the output of flag? Priya, any
Mm.
idea?
No,
one.
Yeah.
I
So
think
right.
it's be okay. Okay, tell.
Yeah. Yeah. Tell. Go ahead. You can tell.
Um, maybe it's be a null value. I think so.
No, no. So what happens here is that first thing is first is going to check this condition. Whatever you're keeping inside this parenthesis, that's the condition. Okay. So this is a condition operator. We are using condition operator greater than. Okay. So we're going to check these two values and check whether it's greater or not. It will return true or false basically. So here 5 is greater than 0. Is it true or false?
It's true.
It's true.
Yeah, it's
So
true.
if this condition is true, then we'll be getting this as the output. So this one will be stored into the flag. I'll show you with the annotation. Yeah, if this is true, this particular one will be stored into the flag. Okay. If that is false, if this condition, see here 5 is less than 0, it is false. So here this is false, hence 0 will be stored into the flag. Got it? I've got
Okay.
two conditions. This is one condition.
Yeah.
This is a false condition. This is a true condition. So this value or this value will be stored here. Here it need not only be a single value. It can again be an expression. We can again give another expression. Okay. So let me do a small demo if you don't mind. The code. Yeah. Yes. Yeah. So here I've taken two variables. A is equals to 5 and b is less than b is equal to 7. So this is the first condition. If a is less than b, what will be the output?
You're asking me.
Yeah, anyone can answer it. Nothing like I'm not targeting you here.
Okay. So A is less than 5 is less than 7.
Statements dot c with some additional statements, some spelling dictionary. This is a spelling correct. Right? Yeah, it is right. Conditional statements. The same and here also. DCC conditional statements. Let's see. Yeah, man, right. Okay. Okay, fine. So whatever, I'll just figure that out.
Mm-hmm.
Mm, yes. Let's see, program. Yeah. So,
It's coming. It is printing all the A is less
yeah.
than B.
Mm, so here we can see this is the output. So what
Mm-hmm.
happens is since A is 5 and B is 7 and since A is less than B, so this is printed. So if I change it, if I change this to A greater than B and if, if I'm again compiling and running the same code,
Doesn't.
it doesn't print because this
Yes.
condition is false. Okay, this is if. So let's go for yeah, else printer B is greater than A. Okay. Yeah. So again, we'll compile and run it. See, right now, since A is not greater than B, so we are getting this particular statement. Okay, this is if.
Yeah.
So here, if else. If you wonder, okay, we can do even if else if ladder also. So that is like, I'll continue the same code. Else if B is greater than A, what happens is print that B is greater than A, and then reader equal to B is equal to A. Okay, there, else. Yeah. So if else if else. Okay. So this is an else if ladder. If else if keep on you can do this else if n number of times. You know that. So I'll do the same code. Yeah. So since B is greater than A, third one is executed. If we say both are 5, then we're going to get B is equal to A. Is it seen?
Yes, yes.
Yeah. So this is if else if is done, and next we have is what is the next one? Switch. Yeah. So comment this. Let's take a variable A. Okay. Switch of A. Case 1. If A is 1, then we'll tell that print A is 1 break. Okay, I'll do this. Copy the same. 3, 4, 5. Case 2 and case 3. This case 4. This case 5. Yeah. I hope the syntax is right now. Or do we have a colon here? It's right. Okay. Yeah. And then we have default as printer is undefined. Yeah. So here I have given 5 cases. So we're going to check A whether it's having whether it's case 1, 2, 3, or 4 or 5. We'll do the same here. And then, okay. Yes. So I hope you can see the output down here. It's telling
A is
A
5.
is 5. So what happens is it will first check for the case 1. Since A is not equal to 1, it skips. Then goes to case 2, no. Case 3, no. Case 4, no. And then comes to case 5. When this is satisfying, then it prints this statement. Okay, this is switch.
Mm.
Any doubt?
No.
Priya, you any doubts?
No.
Okay, fine. So switch is done. Next is we have ternary, right? Ternary operator. Ternary operator. So what is the variable declared? A is 5 and B is 5. Okay. Mm, int flag is int flag, and then flag is equals to, first is the condition. What is the condition? Whether we're checking A is less than B. A is 5, B is 5 here. If this particular condition is true, I want to return value 1. Else, I want to return value 0. Okay. Now, the typing. Printf value of flag is percentage B flag. We've done the same code, compiled. Yeah. 1 second. Yeah. You can see the value of flag is 0. Is it seen? Wait a minute, maybe it's bigger. Yes. Can you notice this? So it's like value of flag is 0. So what happens is I'm just taking this one. It's a integer value, and that's been stored. So this 0 has been stored as a flag. Okay, that's explained. So yeah. So this is about the branching. Coming to looping. So I'll just make it little faster. So looping, guys, we have 3. That is while, do while, and for. And this is the while state. These are the syntax. So what happens is, until the what this is basically an iteration. It's an iteration process. So until the condition is true, the set of expressions will be executed, or this is called as a body. This part is called as a body, and this body will be executed iteratively. Iteratively means it keeps on iterating, looping. Okay. So we have totally 3 types: while, do while, and for loop. So while, what happens is, let's say we have an initialization, we have condition, and we have updation. These are 3 important things. Initialization, like based on condition variable, or the control variable. That is control variable, and that variable will first initialize with a value, some value that's used for iteration part, and then we check for a particular condition, and only when this condition is true, this expression is done. And updation basically for going to the next iteration. That's basically updation. Okay. This is while. Okay, this one, the minimum number of times a body will be executed is 0. That is, only if the condition is true in the first place, only then this set of instructions will be executed at least once. I mean, basically doesn't execute. Only when the condition is true, it gets executed. In do while, what are the difference is that you're first having initialization variable, or say control variable, and then do. This set of expressions is being executed first, and then the while comes, where it checks the condition, whether this condition is true or not. Here, what happens is, this set of expressions, right, or this part of the code, or the body of the looping state condition, it executes at least once. At least once you can see the output, or any expression that's been executed here. That is the difference between while and do while. Okay. Any doubts, or do you want me to explain again?
No, I have no doubt.
Good. Moving to the third one, that is called as for loop. Here again, this is the initialization, or known as control variable, and this is based on, until this condition is true, this set of instructions is being executed. So this updation happens after, once the body is being executed, comes back to the for loop, and it checks for the condition again, and it updates. I'll show you the example now. So fast and simple example. So this is done. So int I, we have I variable. Okay. So first is, we'll do with the while. I is equals to code. Mm, int max is equals to 5. So we'll write out while I is less than max. Uh, so every time we'll check for the I value and we'll check whether its I is less than max. We're gonna do this. Then the value of I is percentage d, then degree percent comma I plus 6. So I hope you guys know that this is a post increment. So once the set of instruction is executed, only then it updates the value. So here, this is the control variable, okay, and this is the condition, and this is the updation, and these are the expressions, okay. Yeah. So I hope everything's right. Mm, good. Good. Can you guys tell me what's happening?
I think it's kept on implementing increment and print, I think so.
So that one, because we didn't initialize the value of I, so I equals to 0. Now,
Versus dictionary.
yes, I know, lot of things. So those kind of errors will not be caught by the compiler. Code something from clear dot program. Yeah. So now it is fine. So I hope you can guys see here. So
Yeah.
value of I. So I starts from 0 and maximum value is 5. So until I is less than max. So it is from 0 to 4. Okay, this is while. Next, let me say this I value is 5 and make this as a that is paste it here and semicolon, very important, and this becomes do. Yeah. So this semicolon is very important here. Do keep a note of it. So this time, see, I is 5 and max is 5. So definitely this condition is not true. Let's see what happens. Program. This statement is executed once because it's a do while. Even though this condition is false, still this particular instruction is executed once. That's the reason we are getting that. Okay, this is do while. Coming to for I hope for I is equal to 0, I less than max, I plus plus. The same syntax value. Okay, this is a for loop. Here, this is a initialization, control, and updation. Okay, and this is the set of expressions that's going to be iterated. Yeah. So this is the same output as we got for while also. So we're getting all the three here.
Mm.
Okay. Cool.
Yeah.
So even this is done, coming to header files. Sorry, I can take a lot of time. Header files is basically a file with the extension .h. So any file with an extension .h, you can tell that is a header file, especially in programming. So what does that basically contain is, it contains a lot of declaration and macro definitions. Okay, like many constants and functions will be put inside this particular file, and we saved as a .h extension called as header file. Why do we do this? Because if you want to share a common piece of code between multiple programs, then rewriting every code, just like a function, here we are going with the file levels. Okay, that is within the code. Here it's between multiple files. So if a single header file is being used by multiple files, that particular function and declaration can be put inside this particular file called as header file. Okay, so what we need to do is first we have to create an header file. So that also I've got an example here for this. Um, this. So yeah, this is one of my header file. Okay, I'm just going to create a function of return type of int. Function name is the sum of two numbers, and it's going to take two arguments a and b, and it's going to return the sum of both. This is basically, and this is the only function inside one file. And I have saved it as sum.h. Hope you can see here. This is the file name sum.h. Okay. In the program, in our main program, what I'm doing is I'm going to include those, and I'm going to utilize it. So if you guys notice here I've used the arrows, whereas here I've used double quotes. That is because if these are like standard, these are the standard header files, right? This stdio.h, math.h, string.h, and what is that? Standard library, stdlib. These are standard libraries or standard header files, and those we need to include. We have to call them by using these arrows. Okay. Whereas this sum.h is something that is user defined. We defined it. So we'll be calling it using this double quotes. Inside double quotes means it's user defined header files. Anything within this arrows is called as the standard header files. Okay. Here, if we see, I have just as a normal program in main, I started with three variables a, b, and output. So result is a double. That is for math.h. Okay. See here, sum out, and the sum out I'm using the function that has been defined inside my sum.h. Here I'm utilizing it a comma b, and I'm printing sum out. Okay, this is an example for the user defined. Whereas this POW, it is an what is it, standard function. It's already a function that has been defined inside math.h. Okay, so show the annotation. Yeah, so this one is already defined inside math.h, and this one it's here. Okay, so don't mind about that. So this is here. Okay, so let's see how this one works. Yeah, let's put the screen. The files program. Yes. So this is already I have compiled this code, and here's the compile file .exe file. So here if you see, we are first printing out sum out, right? The sum out is nothing but it's just adding a and b. 6 plus 7, 13. The output is here 13. Okay. Second is the output of RES. RES is nothing but power of 5 comma 2. 5 comma 2 is nothing but 5 part 2 is 25. 5 into 5. So it is 25.00000. The reason because this particular function takes parameters of data type double. These two are double, and it returns the value of data type double. So this result is a double value. That's why we're getting this. Okay. So this is my header file. Yes, guys, that's all from my side now. Maybe we can give it to Priya. Any doubts before I end this?
No, all clear.
No.
Okay, sir. My part is over.
Priyanka, it's your turn now.
Yeah, okay, 1 minute. Yeah, sorry. First, I don't mention about the operators. I forgot it. Now, coming to the operators, it is a symbols. Uh, there are a type of operators. One is arithmetic, relational, logical, bitwise, assignment, and MISC operators. Now, arithmetic operators are addition, subtraction, multiplication, etc. I mean, division and a module. Right? Next, relational operators are greater than, less than or equal to, greater than or equal to, or not equal to. So coming to the logical operators, and or are not. So bitwise operators are and or and what's this? Okay, left shift and right shift, etc. Okay, so directly I will coming to the topic is functions. So to perform in any task, we want to first create a function. A function can be called as many times, or we can call a function as many times, and it provides, okay, for the function it must be a one name, that's be a function name. And there is a advantages of a function. One is a code reusability and one is a code optimization. Now coming to the syntax to declare the function is, first we want to indicate the return type. Next we want to give a function name, and in the function name we just want to give a data type or a parameter, like okay. Now um, yeah, in a function there is we want to call a function and call by reference. um, let I will tell you a deep declaration. Declaring a function means a variable is equal to function name and so on arguments. Now coming to the call by value and call by function, it means the value being passing to the function, it is locally stored by the function parameter. So if you change the value of function parameter, it is changed for the current function only. Okay, it will not change the variable inside the caller method. Here I didn't show you example, but wait. Okay. um
Any problem?
She is no more in the meeting.
Yeah, Priya, you can continue. Priya, I guess we couldn't hear you. You need to fix your microphone, I guess. Vishnu, could you hear anything?
Neither I can hear. No. Can't.
We couldn't hear you, Priya.
Yeah. Yeah, now I'll show you the example of call by value. So here, okay, there are two methods in a function. One is the call by value, and another one is the call by reference. So coming to that, here we give you original value. Okay, if we modified, okay, it is a true. Sorry, it is a true value, then it will call to the call by reference. If it is no, it will call to the value. So coming to the what is call by value and what is called by reference. In a call by value, the value of the actual parameters is copied into the formal parameters. So okay, in other words, we can say that the value of the variable is used in the function call or in the call by value method also. In call by value method, we cannot modify the value of an actual parameter by the formal parameter, so we can't change the value. The actual parameter is an argument that which is used to the function call, or whereas a formal parameter is used to be as a function definition. So coming to the okay example, I will just show you. I'll show you the program. Okay, and here we are. Okay, we are declaring that there are yeah, we are printing that before adding a value inside the function, we are just giving a number is equal to, wait a minute. Yeah, you can see that we are printing the value. First of all, we are printing the value before adding the value. Before adding the value inside function, number is equal to module d number, etc. So next we are giving the number is equal to number plus. What will be the output of this program is it is a, before function call, the value of the number is equal to 100. After adding the value, okay, after calling the value, okay, uh, after calling, yeah, after adding the value inside the function, yeah, wait a minute, sorry for the disturbance. After calling the function, the value will be also 100. Before, after adding the value, the number is 100, right? After adding the value, it must be 200. But it is false. Then if you come to the function call will be only 100 only. So now coming to the another call by reference. Yeah. Now call by reference is a original value that is modified because we pass a reference. Reference means it is an address. So at the address of a variable is passed into the function call as the actual parameter. So the value of the actual parameter can be modified by changing the formal parameters. Okay. Since the address of the actual parameter is also passed in call by reference, the memory allocation is similar of both formal parameters and actual parameters also. So now in the function, the value will be stored at the address of the actual parameters, and the modified value gets stored at the same address. So now coming to the call by reference example. Yeah. Yeah, I'll tell you call by reference. Here we are printing the value is a before adding the value is 100. Okay, the number is 100, and after adding the number will be also be the number will be added as a 200. And here we are passing the reference to the function. In a main function, then x is equal to 100. Before function call, the number will be 100 by passing the reference. Okay, by passing the reference, the after function call, then it will be changed as a 200. It will be changed as a 200, so it will be incremented. um, that is a call by reference. Okay, if it is not modified, then it will be printed as only 100. If it is if it is modified, then it will be printed as 200. Okay, so now coming to the another topic. Okay, now coming to the storage classes. A storage classes defines as the scope and a lifetime variables. So in a storage classes there are four types of structures. Sorry, four types of storage classes. One is auto, register, static, and extern. Um, no, storage classes. Wait a minute. Okay, what is auto? Auto storage classes is a default storage classes for all local variables. So how will we give this structure? Means it will be an auto int. So int mount auto int means month. So it will be changed as autoly. If you declared a wrong wrong keyword or anything wrong variable, it will change it as a correct word. So the next one is register. The register storage class is used to define a local variables that should be stored in a register instead of RAM. How will be declared as a register storage class is register int miles. I will clearly. So here the static storage class instructs the compiler to keep a local variable in existence during the lifetime of the program instead of creating and destroying it each time it comes into and goes out of scope. I clearly mentioned what is storage static storage class in this PPT. So therefore, making a local variable static allows them to their values between function calls. So the static modifier may also be applied to global variables. Here, the storage classes are used to describe the features of variable and the function. Okay, now coming to the storage class, the storage classes declares the register variables which have the same functionality as that of the auto variables also. The only difference is that is a compiler tries to store these variables in the register of microprocessor. So this makes the use of the register variables to be much faster than that of the variables. So the store, okay, uh, the syntax of this register storage class is, yeah, I declared an example here. Here we are declaring the function, and the global variable is a static int count is equal to 5. So here we are giving us some logic like a while, we are using the while loop, and next the definition is return 0. Okay, this is the function definition, and we are declaring that the static int I is equal to 5 is a local static variable. So here what happened means, the register storage class will register it as, wait a minute. Okay, yeah, the register storage class will be much first. Register variables which have the same functionality. If you have here int count is equal to 5 and int I is equal to 5, we are declaring it as a same functionality. Sorry, this makes the use of register variables to do much better. Okay, when we use the microprocessor, okay, register of the microprocessor in these storage of these variables, it will give register variables to be much faster. Okay, so now coming to the static. Okay, I don't tell about your static, right? Tell you. The static means static is used to declare a static variables which are popularly used while writing the programs in C language. So here static variables have a property that the property is preserving their value even after they are out of their scope. Okay, it will preserve the value if there is if it is out of their scope also. Hence static variables can also preserve the value of their last use there in their scope. So right. And this is the example of static variable. Sorry, I just declare it as a, what happened?
Your screen is not being shared now.
Yeah, okay, it just, yeah, is this visible now?
Yeah.
Hello.
Yeah, it is visible.
Yeah, okay, sorry, before I mentioned that, yeah, before I mentioned that this is the example of register, but this is the example of static variable. Here we can find the what is where we are declaring the static variable. So here we okay, if you want to declare a static variable, first we want to give first we want to give a static name, and after we should want to declare as a data type. Okay, here you can see after void function we are declaring the static int I is equal to 5. Okay, we are declaring the static variable. So when we declare the static variable, it will taking as an input as a I is equal to 5, then it will be incremented, then it will be a 6, and the I is module. Okay, then the I will be printed one by one, it will be printed as 6 7 until we give a perfect value. Okay, until we give a stop value that okay, it will be stopped by the I less than or equal to 10, then it will be stopped up to it will be printed 6 7 8 9 10. Okay, so now coming to the extern extend storage class is used to give you a reference of a global variable. Okay, global variable means here we are declaring a static int count is equal to 5. Okay, before the main we are declaring the global variable, and inside the main we are declaring the local variable. So in the brief explanation of extend storage class is a simply tell us that the variable is defined else where within same block and not within a same block where it is used. So here basically the value is assigned to it in a different block, and this can be overwritten or changed in a different block as well. So an extend variable is nothing but a global variable. Okay, what I mentioned before, when you have multiple files and you define a global variable or a function which will also be used in a other files, then extend will be used in another file to provide the reference of defined variable or a function. So how we declare the extend is, so we are first declaring that void extend storage class. Okay, first we are declaring that, so we can save multiple files in a global variable or a function. uh, and extend is used to declare a global yeah, what I mentioned before. Okay, it is declared as a global variable or a function, and we can have a multiple files in that global variable or a function. So any doubts?
No doubt from me.
I thought, yeah, I thought that I confused both.
It's okay, no problem.
Yeah, okay. Yeah, that's it about storage classes, and I had done. Yeah,
Okay, it is my
now
turn right now.
I think Vishnu.
Yeah, Vishnu.
Yeah, okay. Okay, I'm sharing the screen now. Okay. Um, so now my topics. Can you guys see my screen?
Yeah.
Yeah.
Okay. So now my topics will be recursion and structures. I don't have a PPT for this, but then I've created examples for this so that it is better to it is like a better example for you guys. Basically, recursion is nothing but a function which is called inside a function. So the best example for that will be the Fibonacci series. I'll show you with the example and explain you at the same time. Uh, so this is a Fibonacci series example where you create a function first over here. This is a recursion function. You give a function name as we have to give the function name and the data type for that, and the attribute is a single integer. And then as we know, Fibonacci series starts with 0 followed by 1, 1, 2, 3, and so on. So first we have to create in here we are printing first 0 and the second 1, and then following data will be printed in this return type. So here what is happening is this is a function. As you can see, this is a Fibonacci series function where I'm calling the same function with the same name twice inside the same function itself. So a recursion is example here is explained here. A recursion means a function which is called inside a function. So these are the functions which are called inside a function. So this itself is recursive function, and if you want to print it, you have to again. If you want to print an array, you have to use this. You have to use a for loop. So again, you can tell this also as a function. Printf is a function, and you're calling another function over here. So this also comes as a recursive function. If I run this, you'll get this output over here. 0, 1, which are printing as default over here. If it is 0, print 0, it's getting printed over here. And if it is 1, return 1, will return 1 over here. And then from there, the actual mathematics starts over here, so that it will print the rest of the sequence. So that is recursive function. If you have doubts, you can ask me now itself.
No doubts.
Yeah, no doubts.
Okay, good, clear. Let me comment this out so that I can show you the next example. Yeah. So other thing is a very important thing when you're using any of these kind of numerical mathematical expressions or functions, you have to include a math.h header file, else it will show an error or warnings. So the best practice is to use those header files which are required. So next, coming for the next topic would be structures. So structures are also storage elements which are very similar to arrays and unions. The main difference between a structure and an array is that array contains a set of elements which are having a same data type. But whereas structures also stores different elements of different data types. So if you see here, a structure is always defined outside the main function, just like the function. And it is the keyword for writing a structure is a struct keyword followed by the name of the structure. And then you open the parenthesis, curly braces, close it with a semicolon. If you don't close with a semicolon, it will show you error or it will show you warning. So it is important to close with semicolon. And this is format for defining or declaring a structure. Important thing is that we have to include struct over here. Without that, you can't define a structure and the name of the structure. So inside the structure, as we spoke about that, we can initiate or declare different data types, different elements of different data types. So if you take it as country as an array, having 10 as is the capacity of the array, which is of character, and states or state, which is an array with a capacity of 15 characters, which is our data type character, and language or lang, which is an array of 10 capacity array, which is also of character, and the last one is int. As you see, all the variables which are declared over here are not of same data type. Character, 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 and integer. So this is valid only inside the structure. And if you want to print this, it's like it is valid. If you want to, if you, same thing, it can't be done inside an array. So this should be done outside the main function, which is very important. And then inside the main function, you have to, sorry, wait a second. Come this out. Yeah. So inside the main function, you have to first, again, initiate struct with the same name struct. Struct is a keyword and the same structure name. The structure name is region over here. And we create a pointer variable place and then semicolon. This syntax is for initiating the structure inside the main function. And then for assigning the values for the key, these are called the keys. And for assigning the values for the respective keys, we use string copy, str copy, where we use the pointer variable which points to the particular key. along with separated by comma, and you mention the value of that, close to semicolon. This is very important. So the same thing here, because we are using string copy only because it is a string. Karnataka is a string. India is a string. Kannada is a string. If at all you're using any integer value or decimal value, you just have to place the pointer variable, which is place, and then point out to the particular region. Sorry, point out to the particular region where this value has to be stored. The value has to be stored inside the population key, which is inside the structure. So it is stored over here. So you're just directing the value in towards its respective key. So here in these lines, we have assigned the values for the respective keys which are declared or initiated in the structure. And going on, if you have to print it, just have to say print. You have to call the printer function, give some name, any message for that, and as it is string, we tell it as %s, and we tell him go to new line, and then we have to tell which value you want to print over there. So for the country, we want to print India. So we have to direct India. India will be stored inside the country. So if you write country, it is not enough, but you have to point out where is it. It is in the so you have to again tell the variable, and then with the pointer you have to specify the key. Here also you have to specify the key. Here also you have to specify the key, and then only it will work along with the pointer. And if you come to population, again same thing, place pointer population, place pointer language, place pointer state. So the format is the variable, pointer, and the key. The variable, the pointer, and the key. The variable, pointer, and the key. So if you do this, you'll get it. So it is supposed to print all the values which you have given over here. So let us execute it. Yeah. So if you can see it, this is a structure which is storing these elements of different data types. So if you can see, country is India, state is Karnataka, language Kannada, and population is any number over there. So this is how you define. So this is how you use a structure. Structure is mainly used uh, for storing multiple data types, for accounting business, and for different what do you call that, administrative purposes. So this is easier to use since it has pointers, since it has a defined data structure. It is easier to use for anyone. So if you have any doubts, you can ask me now.
No doubts.
Okay.
No doubt.
So let me see. So structures and recursion have completed my topics, 2 topics. Yeah. I think it's Sandeep's turn now. I'll be unsharing the screen now. Sandeep, can go ahead.
Yeah. Yeah, okay, guys. I'll be covering 2 topics, unions and pointers. Let me keep it fast. So, coming to unions, union is somewhat same as that of structures. Okay, so the key difference is that yeah, first difference is the keyword. Okay, here we are making use of a keyword called union, whereas there we made use of keyword called struct. Okay, that's the first difference. Second is this is a name. It can be any name, but it's not be a part of the keyword. So it can be any name. Let's take, I've given an example here. Yeah, yes. So this is the main keyword union, and let this be the name of the union, datas. Okay. So we're opening the parenthesis, closing it. And here its union is basically a collection of different data types. So I've given all possible examples: int, float, char, and string. So it is a collection of different data types. Okay, same like that of structure. And then we are creating a variable for this particular union called as data, so that you can access it. So it can be one variable here, or it can be an array of variables. So what a similar concept to that of classes in C++, right? There also we have objects, somewhat the same. So here also we can consider this as object for unions. Okay, inside the main function, how we are going to use this is, first, either we can create an object here, or we can create it here. It's called as an union variable. I'm just telling it as an example. Okay, here also we can tell union, and what is the name here? Datas, and we can give a new name, something called data2. Okay, and I can call it as data2, data2. Okay, this can also be done. So let's take the previous examples. Yeah. So what happens here is, I created an union, and this is one of the variable that's going to access all these. Okay, in the main, I'm going to call access each by, like, the first is a union variable name, that is data, and I'm going to use a dot operator that is going to access inside this one. So it's going to access the integer variable a. I'm going to assign a value to it. So what happens is that, so this is actually main copy. Okay, this is the main file, and the data is going to take a copy of this entire one. It's going to take a copy. Same like that of the structures also. Structures also doing the same. Any structure or variable is going to take a copy. So in that copy, we're going to assign the values. For the integer a, I'm going to assign a value of 10. For the float b, I'm assigning some floating value. C is a character C, I'm going to assign a character A. And for the fourth one is it's a character array or a string. So I'm going to do a string copy, strcpy. So for that, I've included string.h. And here I'm copying this. This is a string and copying into the data.str. Okay. Here we're using a dot operator. I hope that's clear. And then I'm going to print it. So clear cd, which folder here? Right. Yeah. Okay. One second. Um, yeah. So hope you guys can see this. It's an integer a. Data. Okay. I'm getting all garbage values here. So what is the mistake in data? The data. I'm taking the data here and assigning the values. Yes, this seems right. Where is the mistake? Please, could you make out some mistake here?
Wait a second, let me see.
It's fetching all the garbage values. I guess I'm making some small mistake somewhere. This is how it is supposed to be. I fine. Just a second. Let me not declare it there and declare it here. Union data. Okay. Mm, to the same. Mm, seems to be a clear one. And there's the wrong. Something, something. Yes, it is. So data is getting corrupted, and I hope this difference. Okay, cool guys. Got the issue what it is. So it's nothing but you have to use one data at a time. So that's the fault. So let's just stop. Yeah, yeah. So I'm using one data at a time and I'm printing it. Using other data at a time, printing it. Okay. Let's try this. So
And does it really affect it?
yes, it makes it.
Okay.
This is why because
Yeah. Oh,
we know that in structure, right? Whenever we are creating a structure, what happens is the size or the memory allocated to it, right? That comes the picture here. So in structure, we know that, yeah. So in structure, when you're creating, okay, let's take this is structure, right? So if I struct, so what happens is entire one piece of code, it takes a total memory of integers 2 bytes, float is 4, characters 1, 4, 6, 7, and it's a string of a character. It's a character string, so 17 bytes. So this total takes 17 bytes. Okay. Whereas in
okay.
union, what happens is, yeah, in union, what's the advantage is that out of all the variables that's been declared here, which has the highest variable, highest size, right? Only that will be the maximum size of the union. So what
Okay.
that means is that it's taking one memory or one memory and it's going to reuse. So each variable is going to reuse only one block of memory. Okay. So I can just show you how it looks with an annotation. So here what happens is we have one single memory of 10 bytes and first A uses it and then A is removed and then B uses it, B is removed and then C uses it, C is removed and then D is using it. So that's the reason we,
So
yeah, so we can use
all
it
that
one, yeah, tell me.
yeah, tell.
Yeah, so that means that we can use each variable one at a time. So what happens, because in the previous example, what happened is that we assigned everything. So in fact, I can show you what happened in the previous example is that we, let me show in, yeah, we can see the here, the string is here is string here, okay. So if I'm taking this piece of code to the down, yeah, this piece of code I'm taking to down. Okay, let the integer be the last one. And as usual, let's just see all this to the top as it is in the first. Okay. Yeah. So if we execute the same code again, yeah. See what happens is again here what happens first A is being assigned to the 10 and now the same space is being taken by C and then B and last is this one. So again put A to the bottom and let's run the same code. Clear. Yeah. I hope you can understand now. See, first is it performs string copy on the same memory. So this piece of code will have a string now. This will have a string. So first string is there, and then we are taking this variable. So this string is removed. The string is removed, and then a character comes, and then we are replacing that with a float. So this is removed. The float comes, and then at last we're taking the integer. So the float is removed. The integer comes. Okay. So this is the memory now. What happens is this one is being shown here. So this is the only memory. So only A is available totally now at the final, and these are trying to display each out of it. Okay, so this is a common memory. So you can first put a value into it, display it, and then we can again put another value and display it. That's the difference. Did you guys understand, or do you want me to repeat again?
Understood. But
Yeah.
so the size of the union will be decided above before the main function itself, right?
Yeah. So here, whenever
Instead, as
whenever you're using union, right? So it will first evaluate each out of this, which one has the highest memory. So in our case,
no,
it
that
is
will
the
get
character.
determined itself.
Yeah.
Okay.
So this is the character of size 10 bytes, 1 byte each, so 10 byte. So that will become the total size available. So this is only because of the efficient usage of memory. Whereas in structure, what
Oh.
happens is if in case we are having almost some 20 variables here, and each is occupying some different, and totally it comes up to 200. In case of unions, it's just going to take the only variable which has the highest size. That may be something close to 50. So that memory is much efficiently used here in union. But as you see here, the disadvantage is that we need to put it. You have to use one at a time. That is the disadvantage of using this. Taking back all. Okay, B is right. C is right. Yeah, yeah. B, C, D is fine. That is the union.
Okay.
Uh,
Okay.
union. Now you can see float is taking 10. So first 10 is put in the common memory, and that has been displayed here.
Mm.
And then character A is put in the common memory, that has been displayed here. And then the string is put in the common memory, that has been displayed. You can see this is string. I've entered the string here, so it's showing string. And then at last 10 is put into the common memory, and that has been fetched here. So we're getting the integer. My
Okay.
clear? Any doubts?
Yeah, no, understood.
Okay, fine. Taking a lot of time.
Yeah.
Okay, last is got pointers with me. Yeah, pointer is basically a variable that holds the address of another variable. Simple as that. Okay. So here I can just show with the basic annotation, and I guess that's sufficient. So let me, if I'm creating a variable A, okay, that is going to create its own memory block. Okay. This is an integer. So if this is an integer, if I tell A is equals to 5, so the 5 will be stored here, and this will have its own address, something like X, 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 X. I'm not sure which one is what. It has some address, okay? So this is a variable, and that's the value inside it, and this is the address. So you want to access this value, you're just going to call A to access the value. You want to access the address of it, so you're going to pass it through an ampersand A, right? This is how you're going to access the address of that particular variable. Hmm? So this is how you're going to. Now what this pointer does is it's actually a variable that holds the address of another variable. So that is defined by this type star pointer name. So this is the type. This is the basic data types in C programming. It can be int, float, doubles, or character, anything. Okay. Yeah, back. So this is for the basic normal variables, right? So in case if you're using pointer, it's going to be like something like this. So I'm going to tell int, no need annotation because I'll do the typing. Yeah, it's going to be int star ptr. Okay, this is my variable. It's of type integer, and this is the yeah, it is a variable. Yeah, I'll show the Okay. Okay, here I'll give an example. So we're going to type create a pointer called PTR in the name of PTR, and this is the first declaration part. Okay, we've got int PTR, and we also got a variable called int a is equals to 5. Okay, yeah. Now we want to access this variable's address. We can access it by using ampersand a. That's how you can access the address of a variable. Okay, and a is going to be the value of the variable. Value of the variable. Now what we're going to do is we're going to assign the address of a into this PTR. So that's like PTR is equals to ampersand a. Okay, and now if you're displaying PTR using a printer, so we're going to get something like we're going to get the address of a. Address of a here. The advantage of this is that if you're using star PTR, if you're displaying star PTR, it's gonna display the value of a. This is the advantage of pointers. Okay, this is the basic concept of pointers, and the best practice here is that whenever we are creating a pointer, so here whenever we are creating a pointer, we always assign it to null initially, and later in the programming we might be assigning, just like here we'll be assigning to any variable, but best practice is that we are always assigning to null. Okay, so this is the basics of pointers here. If you want to move in detail, we can use pointers in arithmetic operations. We can use pointers in arrays, and we can also use pointers in passing in the function parameters. We can put it in parameters and pointer to a pointer. We can point a pointer to a pointer. That's called double pointers. So it's like, yeah, in this case, we have star PTR. I'm going to create another PTR telling int, sorry, int star second PTR. Okay, and this one directly I can tell that second PTR is equals to star PTR. So this is a pointer that holds another pointer. Okay, that is another small concept of pointer. So I guess this much is enough for today. We'll just finish with the basics of pointers. In the next, maybe we'll just do a little more in depth of pointers, and then we can move to other topics. That's fine, guys. Or shall we do anything today? Was I mute till now? Right? No, am I audible? Check.
Yeah.
Okay. Guys, respond. I thought I'm done with it. Yeah. So, guys, this is the basics
No.
of pointers. Any doubts here? Vishnu, any doubts? Okay. So, I guess that's all from my side today. So, the rest we'll cover the coming classes. Okay, guys?
Yeah, okay.
Cool. So, yeah, Priya, you can leave the meeting.
Okay.
Thank you for your time.